Okay, so this is the third video for section 5.3, and it's going to cover objective 3. And objective 3 is to compute at least probabilities. So this is going to be directly related to the complement of an event, which we've talked about before, where the complement of the event was 1 minus the probability of the event. So that's going to come into play here. So the probability that a randomly selected female aged 60 years old will survive the year is 99.186% according to the National Vital Statistics Report. What is the probability that at least one of 500 randomly selected 60-year-old females will die during the course of the year? So it would be cumbersome to sit here and do the probability that one dies, then the probability that two dies, so on and so forth, all the way up to the probability that all 500 had passed away. So instead of doing that, we can do the probability that at least one dies is going to equal 1 minus the probability that none die. If none die, that's the probability that they're all going to survive. So we can do 1 minus the probability that they'll all survive. And again, in the last video, we talked about any of these females surviving is an independent event. So we're just going to multiply that probability together. And if we want all 500 to live, we're going to multiply the probability together 500 times. Again, we don't want to sit here and multiply that number times itself 500 times. So we can just take that probability and raise it to the 500th power. So we're really going to do 1 minus 0.99186 to the 500th power. And when you chuck that into the calculator, you should get an answer of 0.9832. So that would be your final answer. Among 21 to 25-year-olds, 29% say that they have driven while under the influence of alcohol. Suppose that 3 21 to 25-year-olds are selected at random. What is the probability that at least one has not driven while under the influence of alcohol? So again, the probability that we're looking for, at least one has not driven under the influence of alcohol. Again, easier to look at it in terms of its complement. So we're going to do 1 minus the probability that all three have driven under the influence of alcohol. So that's going to be 1 minus 0.29 to the third power, because again, that's the 29% from here. So we're taking that and raising that to the third power. And again, we're finding the complement of that. So that's going to be 0.9756. So that is your probability that at least one has not driven under the influence of alcohol. Okay, careful of the wording on this one just a little bit. There's just going to be one extra step here. So among 21 to 25-year-olds, 29% say they have driven under the influence of alcohol. Suppose that 3 21 to 25-year-olds are selected at random. What is the probability that at least one has driven under the influence of alcohol? So again, the last problem was at least one had not driven under the influence of alcohol. And now in this problem, we want the probability that at least one has driven under the influence of alcohol. So again, we're looking for the probability that at least one has driven under the influence of alcohol. And what we're going to do to find that is we're going to do 1 minus the probability that none has driven under the influence of alcohol. Again, 29% is the ones that have. So if we want the percent that has not, we're going to take that 100% and subtract out the 29 that we've already used, which is going to leave us with 71%. And if we wanted to change 71% to a decimal, it would be 0.71. So in this case, we're going to do 1 minus 0.71 to the third power. Again, because that's the probability that they have not driven under the influence of alcohol. And again, one driving under the influence in no way, shape, or form would affect the second one. So they're all independent. So again, when we chuck that into the calculator, the answer that you should get there is 0.6421 for a final answer there. Okay, so that's going to wrap up pretty much everything from 5.3. So now just a quick recap of everything that we've spoken about in the past two, and including this one, the third video. So the probability of any event must be a number between 0 and 1. So if we let E denote any event, that means your probability has to be 0 is less than or equal to the probability of the event, which is less than or equal to 1. Remember, 0 meaning that there is absolutely no chance of that event happening, and 1 is an absolute certainty that the event will happen. And if you take the sum of all your probabilities and all your outcomes in the sample space, they must equal 1. So again, if you take all your probabilities, add them together, it has to equal 1. Not 0.9, not 1.01. It has to equal exactly 1. If we have disjoint events, so if E and F are disjoint events, that's the one where we're using the word or, then the probability of E or F is the probability of E plus the probability of F. If they're not disjoint, if they have something that's overlapping, we're still going to add the two probabilities together, but then we have to get rid of their intersection. We have to get rid of their overlap. So for example, if you wanted a red card or a king in a standard deck of cards, there's 26 red cards, there's 4 kings, but 2 of those kings are red. So you counted them with the red cards and with your kings. So we need to get rid of the 2 that we double counted. So that would give you a probability of 28 out of the 52 total cards. If E represents any event, then the complement of that event is going to be 1 minus the probability of the event. And then lastly, if E and F are independent events, so if one event has no effect on a second event, then the probability of E and F is going to equal the probability of E times the probability of F. So that's everything from 5.3. So now at this point, once you finish your note packet, you can move on to do the homework assignment.